It's a good day to have a great day. My hearty welcome to all. On behalf of all, I wish to express my heartfelt gratitude to our Almighty for keeping us in the safer zone during this pandemic situation. My humble pranams to our revered Directress Amba, revered Secretary Amba, our beloved Madam Principal, and esteemed Controller Madam for giving me this knowledge sharing opportunity through this e-content preparation. I extend my warm greetings to all the learners. I'm here to share certain views on chemistry in everyday life. Here comes the role of chemistry in everyday life. What is the importance of chemistry and why should we want to learn about it? Chemistry is important in everyday life because chemistry is fun. Chemistry is the study of matter and its interaction with other matter and energy. Everything is made of chemicals. Food, plant, animals, humans, drugs, etc. These are all made up of chemicals and a series of changes are happening due to chemical reactions. Chemistry concepts are important in other disciplines too. It is a key factor to biology, physics, astronomy, cooking, and whatever the field may be. And the chemical reactions occur when we breathe, eat, or just sit. They're happening the chemical reactions. We are connected with the chemistry, but many people are not aware of that fact. Chemistry has influenced our life so much that we do not even realize that we come across chemicals at every moment. That we ourselves are beautiful chemical creations and all our activities are controlled by chemicals. The importance of chemistry in our daily life. Chemistry is very much used in many places in our daily life. These are all the examples. Chemistry and medicine. We need to understand basic chemistry of vitamins, supplements, food, drugs. Either it can help or harm us. All the medicines that we take when we are hurt or sick are all made up of chemistry. The organic matter is used to manufacture medicines such as antibiotics, cancer medicines, analgesics, anesthesia, etc. Next, chemistry and sterilizing agent. Most sterilizing agents are phenol and formaldehyde. These are made up of carbon which are used to kill bacteria and harmful microbes. And the next important thing is chemistry and economics. Many organic compounds such as diamond, graphite, petroleum are considered to be very valuable nowadays. Diamond and graphite are made up of pure carbon. Both of them are useful metals and they're also very expensive. Oil is one of the most valuable resources in the world and economically it is one of the most influential substances. The next importance of chemistry is chemistry and biology. The principles of chemistry are also relevant to biology because cells are made up of chemical substance. An organism produces multiple chemical reactions at the same time. It includes digestion, respiration, photosynthesis, among the others. And the next field is chemistry and food. Chemistry explains how food changes while cooking, how it gets rotten, how to preserve the food, how your body uses the food we are eating, and how the ingredients interact to make food. The next application in the agricultural field. Fertilizer is an organic or an inorganic chemical which is added to the soil to give necessary nutrient to become the productive. Both organic as well as the inorganic fertilizers can maximize agricultural production when used in right amounts. Next, the environmental issues. Chemistry is at the heart of the environmental issues. What makes one chemical a nutrient and the another one as a chemical pollutant? How can you clean up the environment? What process can produce the things you need without harming the environment? Here comes how the chemistry is used in medicine. Medicine is a chemical composition interrelate with the macromolecular objective to produce a biological response. It can be therapeutic and medicinal in properties to diagnose and prevent diseases. That is, medicine interact inside our body with the macromolecular target to produce a biological response. This chemistry is also used to measure how much amount of sodium, potassium and other elements are present in our blood and urine samples. These are all done with the help of the chemistry. And we should know what is a medicine or drug. Those chemical substance which help the living organism for the treatment of disease or to reduce the ailment is known as medicine or drug. The treatment of the disease with the help of drug or chemical compound which destroys the microorganism without causing any harm to our body is called chemotherapy. And the compound used in the process are called chemotherapeutic agents. Various examples are given for the chemicals to be used as a medicine or drug. The first one is antiseptics. These are all the compound which prevents or destroy the growth of harmful microorganisms in our body. Examples for antiseptics are Dettol, Savlon, Cetaphilone, Acryflavin, iodine, methylene blue, etc. We know very well the Dettol. Dettol is a mixture of chloroxylenol and terpineol. It is used to clean the wound. Bithionol. It is added to soap to impart antiseptic properties. It's a good day to have a great day. My hearty welcome to all. On behalf of all, I wish to express my heartfelt gratitude to our Almighty for keeping us in the safer zone during this pandemic situation. My humble pranams to our revered Director Zamba, revered Secretary Amba, our beloved Madam Principal, and esteemed Controller Madam, for giving me this knowledge sharing opportunity through this e-content preparation. I extend my warm greetings to all the learners. Next one, analgesics. These are all the substances which are used as a painkiller, that is, to get relief from pain. It is basically two types of analgesics are known. First one is narcotic drugs. It is an alkaloid type, contains opium as one of the ingredient, and is known as habit-forming drugs because it causes sleep and unconsciousness when higher doses taken. The main example is morphine. The next type of analgesic is non-narcotics. This type of narcotics are effectively known as antipyretics. Examples are aspirin, ibuprofen, naproxen. These structures are given here. Now we are looking at anti-malarial. It is a drug used to cure malaria fever. Anti-malarial drugs are quinine, chloroquine, and primaquine, which are shown here. Next, tranquilizers. These are all the chemical substances which act on the central nervous system. It creates a calming effect. As it is used for mental disease, these tranquilizers are known as psychotherapeutic drugs. These tranquilizers are of two types. One is sedative, that is hypnotic sedative. The drugs which are used to reduce nervous tension and to give relaxation. Example is reserpine. The next type of tranquilizer is mood elevator or antidepressant. The drug which is used for the treatment of highly depressed patients who have lost their confidence. Example, benzedrine, which is shown here. Now we are going to see what is anesthetics. It is a chemical substance which help to relieve pain, or it can be used as a local insensibility to pain and other sensation. It is also classified into two types. First one is general anesthesia. It produces unconsciousness to the person which is given at the time of major surgical operations. It may be in the form of gas or liquid. Example for gaseous anesthetics: nitrous oxide, ethylene, cyclopropene, and chloroform, divinyl ether, sodium pentothal. These are all the example for liquid form of general anesthetics. And the second type of anesthetics is local anesthetic. It produces a loss of sensation on small portion of the body, and it is used for minor operations. It is available in the form of jelly, spray form, or also in the form of injection. Example for jelly form is oxylocaine, for spray form ethyl chloride, and for the injection form it is procaine. The corresponding structure of these local anesthetic and general anesthetics are shown here. Now we are seeing about the antibiotic, chemical substance which are produced from some microorganisms like fungi, bacteria, or mold, and these are used to stop or decrease the growth of microorganisms. In case of infectious diseases, antibiotics work very well, like in case of flu. Example of antibiotics is penicillin, a highly effective drug for pneumonia, bronchitis, sore throat, etc. And the synthetic antibiotics are streptomycin, which is used for the treatment of tuberculosis. The next one is chloromycetin, used for the treatment of typhoid, meningitis, pneumonia, diarrhea, dysentery, etc. And at the last, tetracycline is used for acute fever, dysentery, and urinary tract infections. The corresponding structures of penicillin, streptomycin, chloromycetin, tetracycline is shared here. Now we are seeing about the sulphur drugs. These are the drugs which have great antibacterial powers. These are defined as group of drugs which are derivative of sulfanilamide. Examples are sulfathiazole. It is used to treat severe infections. Sulfaguanidine. It is used for bacillary dysentery. Sulfapridine for pneumonia. Sulfadiazine for dysentery, urinary infection, and respiratory infection. The corresponding sulfur drug examples are shown here. The next agenda of our topic is chemicals in food. In that, we are going to see number of additives, preservatives, oxidants, etc. which are added in our food. First one is food additives. Chemicals which are added to food item to improve their qualities, appearance, taste, odor, nutritive or food value is known as food additives, which are coloring agent, artificial preservatives, stabilizers, binding substance, artificial sweeteners, antioxidants, minerals, vitamins, etc. First, let us see the artificial preservatives. The substances which are used to protect food against bacteria, yeast, and mold are called preservatives. The common example of preservative is sodium benzoate and sodium or potassium metabisulfite, which are used in jams, squashes, pickles, etc. Its preservative action is due to sulfur dioxide, which dissolves in water and forms sulfurous acid, which inhibit the growth of yeast, mold, and bacteria. And also salts of propionic acid and sorbic acid are also used as preservative. The structure of sodium benzoate, sodium metabisulfite is shown here. Next comes the antioxidant. Antioxidants are the chemicals which are used to prevent the oxidation of fat in the packaged foods like potato chips, biscuits, breakfast cereals, crackers, etc. They are said to be more reactive towards oxygen and also reduce the rate of involvement of free radicals in the aging process. The main examples of antioxidants are butylated hydroxytoluene BHT, butylated hydroxyanisole BHA. The corresponding structures are shown here. The next food additive is edible colors. Many types of colors are added to food item which improve the appearance of food item, but in fact really doesn't provide any nutrition to that food. Dyes are classified into natural and synthetic dyes. Natural edible colors or caramel, carotene, saffron, etc. But the synthetic edible colors are azo dyes, which are harmful to young children and asthma patients. Example, tetrazine. It is purely a synthetic dye. Some inorganic salts are also be used as an edible color like iron oxide, which are used to impart red color, and titanium dioxide for intensifying whiteness. The structure of carotene, that is beta carotene, which is obtaining from a carrot, natural antioxidant source. The carotene structure, saffron, and the tetrazine structure is shown here. The next food additive is artificial sweeteners. Sucrose and fructose are natural sweetening agent, but these adds calories to food, promotes tooth decay. So there is a need for artificial sweeteners. Examples are saccharin, aspartame, allitame, sucralose, cyclamate, L-glucose. Saccharin is nothing but sodium or calcium salt which is highly soluble in water, non-biodegradable in nature, and it doesn't provide any calorific value to food. And primarily it is used by diabetic patients. Aspartame is used in cool drinks and ice cream. Allitame is 2000 times more sweeter than the sucrose. Sucralose is trichloro derivative of sucrose. The main advantage is it never provides calories, and also tooth decay is not possible while using the sucralose. Cyclamate is N-cyclohexyl sulfamate. L-glucose. It is similar to D and L sugars. It is also sweet in taste but doesn't provide any energy since our body does not have the enzymes for the metabolism of this L-glucose. The corresponding structure of saccharin, aspartame, cyclamate is shown in the slide. The next agenda of our topic is chemistry in hygiene. Chemistry in everyday life is a theme of science which is all around us. Without chemistry, our life is impossible. We bath, we wash our clothes daily by using different types of body wash, soaps, detergents, and many other types of cleansing agents. But the basic chemical property of all these cleansing agents is their ability to extract grease or dirt and clean the surface of substance on which they are applied. So basically we use soaps and detergent for cleaning purposes in our day-to-day life. These are all chemicals. First, we should know what is saponification. It is a reaction of alkaline hydrolysis of triglycerides of an oil to form a soap is known as saponification reaction. We should know what is soap, what is detergent. Generally, soaps are sodium or potassium salts of higher carboxylic acid such as stearic acid, palmitic acid or oleic acid. Whereas detergents are long chain of alkyl groups. Soaps are extremely important in our daily life as they help us to keep our bodies clean. But the soap doesn't function very well in hard water because it precipitates in it. But the detergents can function in hard water. This is the image of soap formation. That is, this is a triglyceride part of an oil. It reacts with sodium hydroxide or potassium hydroxide. These two components react together to form a soap with the elimination of water and pure glycerin. This is the general theme of the saponification reaction. That is, oil plus a base, sodium hydroxide or potassium hydroxide. It is commonly called as lye. These two react together to form a solid soap. Here comes the cleansing action of soap. With the aid of chemistry, The cleanliness functions of soap can be explained. Soaps are generally sodium or potassium salts of long-chain fatty acid with hydrophobic as well as hydrophilic part. While the hydrophilic part clings to the water when washing, the hydrophobic end clings to the dirt particles. When we wash our hands with soap, the soap molecules bind to the dirt and the oil from our hands. When we wash our hands with water, these dirt and oil particles also get washed away along with the soap and our hands become clean and germ-free. This is the pictorial representation of cleaning action of a soap. This blue area is water. This is the ionic end, that is polar hydrophilic end of a molecule. This long chain is hydrophobic carbon chain. So with this action, our hands get cleaned. This slide shows how the soap works against the dirt or grease. Generally, the soap molecule contains a long chain compound with a polar ionic end and a covalent tail. This is the general representation of grease on the surface and the soap molecule. So first it will get assembled here like this. This hydrophilic head phases out into the surrounding water. And then by the agitation of the mixture results the ball-like structure forming. Here, hydrophobic tails on the inside and the negative hydrophilic head on the outside. There is a repulsion between the negative charges results in an emulsion being formed and the dirt get released. This is the basic cleansing action of soap. Now let us going to learn about synthetic detergent. It is sodium salts of alkyl hydrogen sulfates of long chain alcohols or alkyl benzene sulfonates. It can be used even in hard water because it contains sodium or potassium salts, and their calcium magnesium salts are also soluble in water. But these detergents, synthetic detergents, are not completely biodegradable as they may cause water pollution. There are three types of synthetic detergent. Number one, anionic detergent. A large part of the molecule is known as anion. So this anionic detergent is further classified into two types. Sodium alkyl sulfate. These are detergent which are obtained from long chain alcohol by reacting with the concentrated sulfuric acid and then by the neutralization with sodium hydroxide. These sodium alkyl sulfates are said to be purely biodegradable in nature. The corresponding structure of sodium alkyl sulfate is shown here. Alkyl benzene sulfonate. It is obtained by the process of Friedel-Crafts alkylation in which benzene with a long chain alkyl halide or an alkene or alcohol would react through the reaction called sulfonation and followed by the neutralization with the base. Example is sodium dodecyl benzene sulfonate. The corresponding structure is shown here. The next type of detergent is cationic detergent. It is said to be quaternary ammonium salts like chloride, bromide, acetate, etc., which are found to be expensive when compared to anionic detergent. These detergents have germicidal properties, so used as an germicide. Example is cetyl trimethyl ammonium chloride, shortly represented as CTACl. The cetyl trimethyl ammonium chloride structure is shown here. The next classification is non-ionic detergent. It is in the form of ester with a high molecular weight obtained by the reaction of polyethylene glycol and stearic acid, and also it can be obtained from long chain alcohol by reacting with the excess ethylene oxide in presence of a base. By looking for the cleansing action of these non-ionic detergent, it is similar to that of soap. Example for non-ionic detergent is liquid dishwashing detergent or of non-ionic type. This picture represents the comparison of soaps and anionic, cationic, non-ionic detergents. The corresponding structures are shown in this picture. Here, these are all the questions for your better understanding to sharpen your knowledge. The questions are: name the artificial sweetener which is suitable under the cold condition. What do you call the mixture of chloroxylenol and terpineol? What does the bithionol in soap work as? What happened to the surface tension of water when we add soap or detergent to it? What does the ibuprofen contain? Aspirin is chemically known as. Which medical procedure can arrest the growth of cancerous cells in the body? And give the name of one local anesthetic. And tranquilizers are used for which physical disorder? Here is the answers. To conclude, chemistry is a branch of science which is essential for the study of material and their development for the betterment of humanity. A drug is a chemical agent which is the boon of chemistry for mankind as it provides a cure for the ailment. Food preservatives are added to the food to prevent its spoilage due to the growth of microbes. Some artificial sweeteners are used by the person who need to control their calorie intake. And last but not least, the cleansing agents like soaps and detergent. Detergents with straight chain of hydrocarbons over a branched chain as branched chain detergents are non-biodegradable and consequently cause environmental pollution. Thank you.